Hi. Today I'd like to talk about something that I would like people who are doing their own do-it-yourself repairs to just think about so that their stuff doesn't wind up here. So a very common thing that people will do in changing the battery is they will use a metal pry tool rather than their fingernail or plastic pry tool. And a lot of people have said, Lewis, why are you using metal? Don't you know that metal scratches things? Don't you know that metal conducts electricity? And yes, I know that metal conducts electricity. That's why I don't touch metal between 2 points that I shouldn't. And that's also why I don't touch metal on something that I don't want to scratch. Yet, if I were touching if I were like right next to 2 points that do conduct electricity, I would not put the metal there. I'm thinking about these things. And this is something that I want you to be thinking about, particularly when you're changing the battery in one of these machines. So just to give you an idea of what it is I'm talking about, let's just take a look at where the battery connector is over here. So let me just get the microscope into focus, since it's kind of out of focus here. I think I kicked it earlier by accident. Here we go. Gotta move it up a little. Do this. Okay, so see how there's the battery that plugs in over here, right? So this is the battery, and then there's all these little metal contact points. Well, these metal contact points are each attached to the pin on the battery. So you have pin, 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 and so on and so forth. So what I will do is I will use my fingernail, shove it under there, and rip this out. And if you have a knockoff battery, it'll be a little more annoying than if you don't. And what a lot of people I see doing, what they do is they use the end of their screwdriver, or they use a spatula, something like this to kind of jimmy in there and rip their battery out. And what happens is when you do that, the metal screwdriver touches over here. Now I want to show you why that is a really bad thing and how that's going to cause a lot of nastiness to happen to your machine if you do that. So I'm going to open up the schematic in the board view for one of these model boards, just so I can give you an idea of what's going to happen. So let's just see what the pins over here do. So I'm going to go over to J6950. Let me just set this up so that you can see what I do on the other screen here. Okay. I don't want to see myself. Turn myself off. Come on. Go away. Go away. Here we go. Go fuck off. All right. So right over here we have the battery connector. So let's just scroll over to the battery connector. Now over here you have pin 9. Pin 9 is going to be PPV bat G3 hot connection. So this is going to be the actual power connection. This is going to be where the 12.6 volts comes from the battery on pins 9, 8, and 7. Then you have the pin right next to it, which is pin 6. SM bus, SMC, BSA, SDA. So SM bus, that's going to be a type of communication between the battery and the SMC. Now let's take a little look at where that goes to, right? So that also goes to the battery indicator. That goes to this ISL6259 chip, which is the chip that controls charging the battery and also creating PP bus G3 hot. But if we go a little bit further down the line, you'll see that this is also part of a data line that's going to be talking to the SMC. So see here, this is where the battery is going to talk to the SMC. And this is the most important part over here in the schematic, where it shows you all the different connections. So you have the SMC talking to the battery charging chip, which then talks to the battery. Now, a data line usually works based on a specific set voltage. So the whole idea here is that there is going to be a voltage that is always present on the line, and anytime one of these chips wants to talk, what it's going to do is it's going to pull the line down to 0. So let me just I'm going to try and find an example here in one of the lessons that I usually use for the people who come for the course. Let's find this. Blah, blah. Here we go. Open copy, and so we're going to find a data line. I know I'm not editing because I'm a lazy fuck. All right, so here we go. So you have pull-up resistors, which are going to pull the data line up to a certain voltage, and then you have the actual data line itself. And it's going to look something like this. So here's the 3.42 volt side of that pull-up resistor. So see over here, it says PP3V42 over here. In the schematic, it says PP3V42 on this side of the resistor. So it's going to pull the line up to 3.42 volts. And over here, I think I was using a knockoff charger, which is why it's rippling so much. Now, on the data side of it, you'll see a bunch of pulsing. So anytime the battery or the battery charger chip or the SMC want to communicate, they'll pull the line down, and these pulses over here are communication. So how long is it pulled down or pulled up for? You know, it's pretty, just think of it like ones and zeros. At the top of the line you got a 1, and at the bottom of it you have a 0, and it's computer communication. Don't ask me what any of this shit means. I have no idea. But this is communication, right? So you have all of that happening on this data line over here between the battery, the SMC, and the charger. Now this is working off of PP3V42, which is the 3.42 volt power line. That means that this is a 3.42 volt data line. So you have this over here, which is your 3.42 volt data line, SM bus, SMC, BSA, SDA, right down here. If you see where the mouse is moving on the bottom of the screen, that's where I can tell that pin 6 is that data line. Yet on pin 7, you have a 12 volt connection. So what do you think is going to happen when you send 12.6 volts to a 3 volt data line? And everything on that data line is now destroyed. In particular, the SMC. And the reason this is important is because the right to repair bill didn't pass. So if you are just changing the battery in your device and you screw up and you're using your flathead screwdriver and you put your little flathead screwdriver where it's not supposed to go, now it's not a question of me buying that chip with programming. Now it's me buying a donor board from China, waiting 6 weeks for it to get here, taking the SMC off of that donor board because it comes with programming. I can't buy a new chip because I'm not allowed to read the programming off of this one. Putting 96.2 millimeter balls on it manually and then soldering it on. And you may ask, well, isn't it your job to have an SMC for this? Isn't it your job to have the tools to do your job? This is a 6-year-old board. I mean, I don't get a lot of these in. So if somebody asks me to fix it, I can, but again, and this is the thing with that right to repair bill that I don't think a lot of people get. It's not going to stop me from doing the job. It's just going to cause me to have to tell somebody it's going to take 6 weeks instead of it's going to take 2 days. And instead of the money going to the manufacturer, the money is now going to somebody in Taipei or Shenzhen who's digging these boards that I buy with holes in them out of a garbage. Again, it's not going to stop the process. It's not going to stop it at all. It's just going to make it a more painful process for me, a more painful process for the customer, and it's going to keep the money from going where it could go. And the money could go to Apple, the money could go to the manufacturer of the chip, or the money could go to somebody who's pulling crap out of a dumpster in China. It's not going to stop the economy. It's just going to put the money in somebody else's pocket and make everybody a little bit less happy with the process. The user is less happy they have to wait. The user is less happy that the battery is screwed into the machine and is not really great manner. And I'm less happy that I have to deal with that entire process altogether. And one thing that really kills me with this right to repair bill and the people who are saying, if you don't like it, you can vote with your wallet. I mean, none of the manufacturers now release any of this information. It's not like Apple is the only one that doesn't release schematics or any of this. None of them do. So there is really no voting with your wallet. And people will say, well, if you don't want it, then you can just not buy that stuff. What about cars? What about automobiles? Because a lot of people who say that stuff, I don't think they realize that there was very similar legislation passed in the automotive industry. And they go, oh, it's not related. Well, how is it not related? Cars are a ubiquitous item that we use all across the country that people expect to be able to have repaired by somebody but the dealer if something goes wrong with it. You don't tell people, oh, you could vote with your wallet and walk 90 miles to work. If you really cared that much, you would just stop buying cars and find a job closer to your house. Like, you don't hear that kind of ignorant shit being spouted in other industries, yet for some reason in our industry, it's totally okay for that type of ignorant horse crap to be said. And even after the right to repair bill was passed in the automotive industry, you don't see mechanics, designing hybrid cars in their garage because there's this whole thing on intellectual property and we want all the stuff required to make the device. We really only want what's necessary to repair it. If you give me a schematic, a board view, and programming to the SMC, I'm not going to sit here assembling 10-layer MacBook PCBs in my little shitbox of an office. The same way that the mechanic is not going to assemble a Toyota Prius because you give him a tool to tell what's going on with the car. Anyway, Point being, if you are going to take your battery out and you are going to use a metal tool, you can use a metal tool to remove the battery so long as you make sure that you don't touch any metal contact points. Or if you're not sure if you're going to touch metal contact points, if you think you don't have a steady hand, then use your fingernail or use something else, but don't touch the points on the battery, because if you short the 12 volts or the 8 volts of the battery to the 3.42 volt SMC data line, you're going to have an X in the corner. It's never going to see the battery, and you're going to wind up paying somebody like me too much money to fix what should have never happened in the first place. I hope this has been informative, and that's it for today.